evaluation. Our team members are Ananya, Jeevan, Dhriti. We are presenting this presentation under the guidance of Sumanama. Next slide. Contents, which includes introduction, experimental setup, implementation steps, observation, comparative evaluation, and conclusion. Next step. Introduction. Virtualization allows us to run multiple operating systems on a single physical computer. For example, on one laptop, we can run both Windows and Linux together. It works by creating a virtual environment that behaves like a separate computer but uses the resources of the host system, such as CPU, RAM, and storage. The main software that enables virtualization is called a hypervisor. Some examples are Oracle VirtualBox, VMware Workstation, and Microsoft Hyper-V. The hypervisor is responsible for dividing the hardware resources among different virtual machines. Each virtual machine can run its own operating system independently. So one virtual machine can run Windows, another can run Linux, and both can work on the same host machine. So virtualization helps us use one computer as many virtual computers at the same time. Next slide. Experimental setup. Now I will explain about the experimental setup used in this project. Our host machine is the main physical computer. It has a processor like Intel i5 or i7 or Ryzen, RAM 8 to 16 GB, storage 512 GB SSD or 1 TB HDD. Host operating system is Windows 11. For virtualization, we used Oracle VirtualBox, which is free and open source software that helps to create and manage virtual machines. The guest operating systems installed inside VirtualBox are Ubuntu 22.04 LTS, Windows 10. So we used one physical machine, but inside VirtualBox we created two virtual systems, one with Ubuntu and one with Windows. The setup process included creating new virtual machines, allocating resources like CPU, RAM, and storage to each virtual machine. Next, installing the selected operating systems using the ISO image files. After setup, both virtual machines worked smoothly on the same host, and we could easily switch between them. Next slide will be continued by Ananya.
Good evening, I am Ananya. So coming to implementation steps, using Ubuntu, this slide explains how to monitor system performs in a Linux machine, especially in Ubuntu. Open System Monitor, we have access to System Monitor tools using the application search bar or by using the command. This tool helps us to see all running processes. Next, sort by CPU or memory. We sort the process based on CPU or memory usage by clicking the column header. This helps identify which process is using the most resource. Next, observe key columns. We have observed important values like CPU percentage, memory usage, disk activity, and priority. It helps in understanding how easy program uses system resources. Switching to resource tab, the resource tab gives us a broader overview of CPU usage graph, memory and swap usage, disk of input and output. So this basically informs the system monitor to check resource usage and identify heavy process and understand the system performance. Moving on to the next slide. Windows system. Here we have used Windows 10. This part explains how to do the same thing on a Windows system using the task manager. First, we have to open the task manager. We press Ctrl Shift Escape or right click the taskbar and choose the task manager. Next, we have to expand the view. If task manager opens in a simpler way, we click on the more details to see all the processes. Next, go to the process tab. The process tab shows both apps and background tasks. Column shows CPU, memory disk, network, and power usage. Next, after the process, we have to sort by CPU or memory. We click on CPU or memory column to sort and finish which application uses the most resource. Example from screenshot. CPU usage shows around 11% for a process. Next, going on to the performance tab, it's optional. We can use or it's just we can have an option towards it. This tab displays live graph of CPU, memory disk, and network usage. It helps analyze performance and visualize. Record key data, we take notes or screenshot of important observation like top process and high resource. So in Windows, Task Manager helps us to monitor CPU, memory disk, and network usage and identify heavy applications used in it. Next slide will be continued by Jeevan.
Good evening, everyone. Myself Jeevan. I am explaining the observation in the Linux system monitor Ubuntu. Total number of processors displayed, for example, 50 plus whatever we have seen in the screenshots. Example of high memory usage in the screenshot, the process genome shell by the user Ananya P is using 250.2 MB memory and the CPU 0.52%. Many processors show CPU 0%, indicating the idle or minimal usage. Some processors show memory usage in the few MB range. For example, 3.5 MB, 4.8 MB, etc. For background, for the background, some processors show disk read or write the columns mostly not available or very low for many processors, implying minimal input at that moment. Priority column shows that a normal for all the listed process. Observation that the system appears to be relatively idle state for a few processors or actively consuming CPU memory usage in a moderate and the input is low. Next slide. Uh, Window Task Manager. At the top, overall CPU usage is visible at 11% and the memory usage is at 35%, as we seen in the screenshot. The app, the app section lists major application, for example, Microsoft Edge consuming 467.2 MB memory, etc. The background processor section shows 30 processors as seen in the screenshot. Many are using very low memory less than 10 MB and 0% CPU. Disk usage is shown as 3% and the network is 1% in the header area of the screenshot. Power usage for the many processors is labeled very low. Observation: similar to the Linux system, the Windows system is not under heavy load, but the CPU and the memory usage are a modest and background processors are mostly idle or light usage. Next slide will be continued by Dhruti.
Good evening, I'm Dhruti and I'll be doing comparative evaluation. So this slide presents a comparison between Linux System Monitor and Windows Task Manager based on different performance parameters. When we look at CPU load, Linux shows very low usage because of most its background processes use almost 0% CPU, whereas Windows has a slightly higher overall load of around 11%. In terms of memory usage, Linux runs moderately with a few processors taking around 250 MB, but Windows uses a larger portion of memory, about 35% of the system, because it runs more background services. And Linux also shows more user processes, but most of them consume very minimal resources. On the other hand, Windows displays both apps and many background processes. And moving on, and also going to the disk I/O activity is also very low in Linux, with many entries showing no activity, while Windows shows around 3% disk usage, but still minimal per process disk operations. Both operating system shows that their background services use very little CPU or power. So overall, major applications do not show any spikes on Linux, while some Windows apps like Edge use more memory. And finally, both systems indicate that the system is in an idle or low usage state. And overall, Linux appears lighter and more resource efficient, while Windows handles more background tasks. And moving on to the next slide. So to conclude this experiment, the virtualization activity was successfully carried out using Oracle VirtualBox. We created and configured multiple virtual machines with different operating systems such as Ubuntu and Windows 10. We then compared their performance based on CPU usage, memory consumption, boot time, and overall responsiveness. From these observations, Ubuntu performed better as it was faster, lighter, and more resource efficient compared to Windows. And also, however, Windows 10, although it used more system resources, provided better compatibility with applications and offered a very user friendly interface. And so overall, the experiment clearly shows how different operating systems behave in a virtual environment and highlights the strengths of each system. Thank you.